Now let us consider group transfer reactions. The group transfer reactions are intermolecular sigmatropic rearrangement reactions in which a group other than hydrogen is migrated, and it can be represented as Ig, where I and J both are equal to 3. So it is represented as a 3 sigmatropic rearrangement reactions. Under the group transfer reactions, two important classes are there: Claisen rearrangement and the cope rearrangement is also there. So let us consider the first example, that is Claisen rearrangement. In Claisen rearrangement, as earlier said, it is a 3-3 sigmatropic rearrangement because it belongs to the group transfer reaction in which the allyl vinyl ethers is converted to corresponding gamma delta unsaturated compounds. So it is the reaction in which a carbon-carbon single bond is formed, where reaction is a concerted process in which the bond making takes place simultaneously. The reaction also takes place without catalysis. So the example for this reaction is, that is allyl vinyl ether. This allyl vinyl ether, when subjected to heat or Lewis acid, it undergoes a electrocyclic reaction and forms this gamma delta unsaturated carbon compounds. While understanding mechanism, so let us understand this mechanism. While understanding the mechanism of such type of reactions, sigmatropic type of reactions, the one thing should remember that a old sigma bond is going to be broken down. In case of old sigma bond is going to be broken down, is cleaved, and the another thing is that new sigma bond is going to be formed. New sigma bond is formed. So these are the two important steps. In case of sigmatropic rearrangement, old sigma bond is broken down and new sigma bond is going to be formed. Similarly, in this case, the sigma bond is going to be clear. So let us consider this example. Okay, now this sigma bond is going to be clear. Right, I'm going to number the system, that is 1, 2, this is 3. Again, this is 1, 2, 3. Okay, now the bond is going to be cleaved like that. The migration of sigma bond takes place like that. The bond is going to migrate here. This bond is going to be migrate here, and this bond going to be migrate here. So due to this migration, a 6-member electrocyclic transition state is formed. So the transition state will be, the dotted lines indicates the new bond formation. So where it is new double bond is formed. Okay, now here it is oxygen is there. So this is transition state, which is 6-member transition state. Now when the transition state is going to be collapse, it forms a product like that. Now here it is, a new sigma bond is going to be formed. So this one is a new sigma bond is formed. And here it is, sigma bond is broken. Okay, now this is a functional group, right? This carbonyl being a functional group. Now next to the functional group is always alpha carbon atom. This is beta carbon atom. This is gamma carbon atom, and this is delta carbon atom. So now the gamma and delta represent the position of double bond. Here it is. This gamma and delta represent the position of double bond. So the molecule known as gamma delta unsaturated compounds. Okay. Another thing is that why this reaction is a 3,3 sigmatropic reaction. So now look at the reactant side. We start the numbering where the bond is sigma bond is going to be clear, right? This oxygen carbon sigma bond is going to be clear. So we start the numbering from here. So after cleavage of the bond, the numbering should be same for both the sides. So here it is 1, 2, 3, and here it is 1, 2, 3. Okay, that's why we are going to cleave this bond. After cleaving this bond, right, the product is going to be formed. This product is there. Similarly, this is the new bond is formed. So in this case, if we look at the position of numbering system, here it is also. So the numbering should be like that. So this should be one number, this should be 1, this should be 2, and this should be 3. Similarly, this should be 1, this should be 2, this should be 3. So the position of this particular groups, in the previous case it is at 1, 1 position. After the formation of product it is at 3, 3 position. So that's why the reaction is a 3, 3 sigmatropic rearrangements. This is sigmatropic rearrangements. Okay, now consider another example. So this is the allyl phenyl ethers. Again, it is a 3, 3 sigmatropic type of rearrangement in which the allyl phenyl ether gives an intermediate which converted into the dione, and that dione is tautomerizes into aromatic enol systems. So consider this example. Now let us consider the mechanism. Okay. Now in this case, this sigma bond is going to be clear. The numbering should be start. So here it is 1, here it is 2, and here it is 3. Similarly, here it is 1, here it is 2, and here it is 3. So the migration of bond takes place here like that. This bond going to be migrate here. Now this bond is going to be migrate at this position. So due to this migration, a six member electrocyclic reaction transition state is formed. So this is six-member transition state. When this transition state is collapsed into the product, it gives this dione, and this dione is going to be tautomerized like that. Now it forms a substituted phenol. This is substituted phenol, or we can say that aromatic enol is there. Now this substituent is at ortho position. If you look at the migration of this particular group takes place at the ortho position, right, in the product side. If the any substituent is present at ortho position, then what should be the product? Now in this case there is no substituent at ortho position. Here it is no substituent at ortho position, so that particular group migration will be occurs at this position. Okay, if the substituent is present, what will be the product? Now let us consider the same example with the substituent. Okay, we are going to consider the same example with the substituent. Again, this sigma bond is going to be clear. The numbering should be start from 1, 2, and this is 3. This is 1, this is 2, and this is 3. Okay, the migration of bond will be take place like that. And the product is this dotted line indicates the bond form and bond clear, right? So after the cleavage of this 6-member transition state, we get the intermediate like that. Double bond O. Here it is, R group is there. R group is there. So this type of intermediate we get. But due to the presence of this substituent, the product is not at this product does not stop at this step. So it again migration takes place. So what is happening here? The bond is going to be attack at this position. This double bond is going to be migrate here, and again here it is. The product is double bond O. This is R is this double bond is there. And last one, it is 2 taumerization. 2 taumerization is there. So this hydrogen is going to be migrate from here, here, and finally it forms aromatic enol. The product is here. This is R group is there. Okay, this is para substituent. If the substituent is there, then this type of group migrate at the para position. Now let us consider a second example, that is a co-rearrangement. Again, as earlier said, the co-rearrangement also belongs to the group transfer reaction, so it is a 3,3 sigmatropic rearrangement. Now this reaction involves isomerization of 1,5-dienes to its corresponding 1,5-dienes. So the isomerization is there. It can only detect when the 1,5-diene substrate is substituted. Let us consider this type of example, that is 1,5-dienes. What is happening? Again, here it is also sigma bond is going to be clear. This type of sigma bond is going to be clear. Numbering should be there, that is 1, 2, 3, 1, 2, 3. So the bond is going to be clear like that. And this bond should be here. And again, it involves a 6-member transition state. So this double bond is going to be broken, this double bond is going to be broken. Okay, this is the transition state. The product is so you can see that this particular isomer, this particular compound is isomerized into its corresponding 1,5-diene. So both are 1,5-dienes. This is also 1,5-diene and this is also 1,5-diene. For sake of convenience, we can number this system also. So we are going to number the system, that is one. Here it is 1, 2, 3. Here it is 1, 2, 3. So you can look at the position. When the starting in the starting method, the bond which is going to be clear, that number should be at 1 and the double bond is at 3 position. Similarly, in the product case, the new bond is going to be formed, right? The starting bond is at 1 position. Now in the product case, it is at 3 position in both the ends of this particular molecule. So the rearrangement is 3,3 sigmatropic type of reaction. Sigmatropic. rearrangements. Now look at the second example. As earlier said, this type of reaction are influenced by the presence of substituents that can be brought into the conjugation during the rearrangement, which favors it in one direction and lowers the activation energy such as such process. Okay, it should be lowers. It should be W naught. Okay. Now here it is also we are going to cleave this bond, and numbering should be here, that is 1 2 3. This is 1 2 3. The bond is going to be cleave this sigma bond like that. Migration will be there. Okay, so pH, here it is, pH is there. So this is the transition state. After the transition state, the product is going to be formed. Now here it is, you can see the new sigma bond is formed, and the numbering should be here, that is 1 2 3. This is 1 2 3. Now here you can see the position of substitute in the reactant side, it is at 1 1 position, while in the case of product side it is at 3 3 position. So it becomes a 3 3 sigmatropic type of rearrangements. Sigmatropic rearrangements.